Did you know that 1 kilogram of plasma a day, something like this, can produce enough energy for 250,000 homes? That's more powerful than the hydroelectric plant behind me.
Atoms are the building blocks of matter. The difference between an atom of gold or an atom of oxygen is the amount of positive charge, called protons, inside the nucleus. Every atom has kinetic and potential energy, and the measurement of this average internal energy is called temperature. Now see the element that I have here. It's conformed by millions of atoms or molecules.
Inside it, intermolecular forces are attracting the neighboring molecules. In solids, the intermolecular forces are higher than the internal energy, and the particles variably vibrate. In liquids, the internal energy is enough to move the molecules over one another. And in gases, the intermolecular forces become negligible because the internal energy is way stronger.
After the gaseous state, how do we provide enough energy to create plasma?
Atoms are conformed by a nucleus that consists of positive charged protons and neutrally charged neutrons, and by electrons, which are negatively charged particles. The tendency of an atom to attract an electron is a chemical property called electronegativity. So, when we add more energy, the extra energy goes to separate the electrons, overcoming the electronegativity and escaping the atom. The free electrons you see allow us to conduct electricity in plasma.
One of the most common ways of energizing plasma is using electromagnetic waves, which are just the vibrations of these electric and magnetic fields. If we use electromagnetic waves at the correct frequency, we can create resonance. Electromagnetic waves are very common, and all of them have the same speed in a vacuum, which is 3 × 10⁸. That's the speed of light. But different electromagnetic waves have different frequencies and different wavelengths. The more frequency an electromagnetic wave has, the more energy it carries. From more to less energy we have gamma rays, X-rays, ultraviolet light, all the light we can see, infrareds, microwaves, and radio waves. Oof, it's lunchtime. Now that we're in the kitchen, let's see how we can energize the substance with microwaves and generate plasma.
We put cork circles so that the flame of the match receives oxygen. We need a glass container on top to contain the plasma. Kitchen microwaves have a magnetron, which is a device that generates microwaves. Microwaves are used instead of another more energetic wave to generate plasma, because we want to create a resonance with the gas. And that's how you create plasma in a microwave.
Here in Costa Rica, we are part of the ongoing efforts to have a better understanding of plasma and all its potential uses. Some examples of this are the Costa Rican Institute of Technology and Ad Astra rocket company. What I have behind me is like a sun on Earth. This device is called the STELLARATOR. It allows to generate the energy of the stars here in Costa Rica.
Given that plasma particles vibrate in a specific frequency, microwaves are used to generate a resonance, a phenomenon that increases the amplitude of the vibrating objects. Coils around the device create a magnetic field that can contain and move the plasma. This occurs because plasma has charges. Plasma can be used for space exploration as well, as Ad Astra rocket company does in its passenger. To direct the plasma, the Vesemir uses superconducting magnets, so that no energy is lost as heat. Most people have not realized the importance that plasma has for our survival. 99% of the universe is plasma. Clean energy. We could go to Mars in about 30 days. And the 2.12 billion tons of waste that we produce every year could be disintegrated with plasma. The power is in your hands.
Please like,